Okay, for our sample problem number 2. Okay, so if the car decelerates uniformly along the curved road from 25 meters per second at A, so this is a curved road. So 1, 2, natay duha ka curve. So from point A to point B to C, then atong radius curvature is just 300 meters. So ato ang initial velocity. So velocity at this point niya is 25 meters per second and it is decelerating uniformly. Okay, this is a constant acceleration. So it decelerates. This is a negative acceleration, constant. So we can use the kinematic equation on constant acceleration in this problem at A. So from A, this is the velocity of the car is 25 meters per second. Then hinay man siya. Pag abot niya sa C, ang iyang velocity at this point sa C, not dili dire sa B, dire sa C, is 15 meters per seconds. And then we were asked the acceleration of the car at B. So, naatay velocity dire sa A, naatay velocity ni C, pero wala tay velocity ni B. Di pa ngayon tawag acceleration dire kay B. So, unsa may buhaton na to ani nga equation. So, we use the constant acceleration nga formula from the kinematic equations. Okay. So, let's write down the givens. Okay, so the given. Ang given na to na tay rho equals to 300 meters. Velocity at A is equal to 25 meters per seconds. Velocity at C is equal to 15 meters per seconds. And then, naadin tayo S, no? Let's say this is S1 and then this is S2. So, itong S1 is equal to 250 meters. S2 is 50 meters. So, ang total position nga travel niya from A to C, yung total distance nga na-travel is just equal to 300 meters. 250 plus 50. Yung sa may buhato na to ani. To get the acceleration of the car at B, so, di ba, acceleration of the car at B, so magamit na tag subscript. So, it pasabot ani nga acceleration is at B is equal to tangential acceleration plus the normal acceleration of the car at B. So, mo siya ato ang pangitaon. We do not know this. We do not know this. So, para makuha na to ni sila, we need to get also the velocity at V, which is also unknown at this moment. Okay. So, using the kinematic equation, so natay velocity, and then, unknown ang acceleration, natay positions. Then we can use katong formula nga, square of the final velocity is equal to the square of the initial velocity plus or minus twice the acceleration times katong delta S or displacement times the final position minus the initial position. So, naman value na to is an A and C. So, ang C is ang final position man. So, ato ibutan diri sa final position is ang velocity at C, which is 15 meters per second squared. So, squared. And then, the initial position, kaya diri man ta nagsugod, iyang dagan ay paingon diri, that is 25 squared, plus or minus, since this is decelerating, so we do not use the plus, we use the minus, 2 times the acceleration. So, unsa ni siya nga acceleration? Again, ang acceleration nga subay sa pagdagan sa velocity or dayang speed is the tangential acceleration. Since iyang giingon diri nga decelerate uniformly, so ang tangential acceleration at B, tangential acceleration at A, tangential acceleration at C is just the same. We can use just the tangential acceleration A something symbol times the final position niya. So again, from A to C mo ni ang final position, di ba? So yung total nga na travel from A to C, that is 300 meters minus yung initial position. So ang position at A is 0, of course. So from this equation, we can solve for the tangential acceleration, simplifying the problem. So tanan unknowns is the unknowns on the left hand side, tanan constant on the right hand side. So we have 280 times 300. because 300 minus 0 is equal to 25 squared minus 15 squared. 25 squared minus 15 squared, pila man na siya? That is 400. That is equal to 400. So, dividing the whole equation with the constant nga nakaabay ni tangential acceleration para ma-solve na ang problem. So, natin tangential acceleration equals to 400 divided by 2 times 300, 0.667 meters per second squared. So, since this is decelerating, so this is a negative acceleration. So, nanatay tangential. So, sa may buhato na to, pangitaon na to si normal acceleration at b. So, para solve na to si normal acceleration at b, di ba ang normal acceleration at b? So, kinahanglan na to ang velocity at b squared over rho. We have the rho, unknown ang velocity at b. So, saan na po ibuhato na to? Using again the kinematics equation, di ba? We can establish this relationship. Final velocity, so from A to B. So, kaning first na to is from A to C. Here, A to B nga relationship ato ang pangitaon. So, final velocity is from A to B. So, final good si B nga part man. So, squared just equal to VA squared because initial dili nagsugod diyang dagan minus 2 times AT. So, tangential acceleration times yung final position here, SB, minus the initial position at SA. So, ilang mo kalibog ganing natay SB niya, kani S, SI, SA. So, ang concept lang is this is the final position. We can use S sub C here and then S sub A. Basta kasabot lang ita nga final position, una nga position. Final position at B kay gikan diri pa diri mo man ning ulahi nga naabtan niya. Okay, so the velocity at V is unknown, VV squared. Velocity at A is just 25 squared minus 2 times we already have the tangential acceleration. So, 0.667. So, wala tanang negative. It is because we already applied it here. No? Minus because it is decelerating. So, position at B. So, from A to B, ang distance is 250 meters. Position at A. So, from A to A, that is 0. Just 0. Simplifying here, we can have that the velocity at V squared is just equal to 25 squared minus 2 times 0.667 times 250. We have 291.5.50. Extracting the whole equation into square root para makuha na to ang velocity at B. So, itong velocity at V is just equal to 17.073 meters per seconds. Then, we can solve for the normal acceleration. Okay. So, normal acceleration, di ba, A sub n is equal to at B is VB squared over rho. Substitute this, 17.073 squared over ang rho na to. What is again our radius? Our radius is 300 meters. 300 meters. Over 300 meters, we have a normal acceleration at B equal to 17.073 squared over 300, 0.972 meters per second squared. We already have the B, the normal acceleration at B, and then the tangential acceleration. Therefore, we can solve now for the magnitude, nagipangita, the acceleration of the car at B. So, the acceleration of the car at B is just equal to 8 tangential acceleration squared plus normal acceleration at B squared equals to negative 0.667 squared plus 0.972 squared. Subtract all them into the square root. So, our acceleration at B is just equal to negative 0.667 squared plus 0.972 squared, 1.179 meters per second squared. So this is our final answer.